Hello and welcome to the final level of this course. In this level we will be specifically discussing about integrated circuits and their applications, but before that we will talk about photoresistor. So what is a photoresistor? Photoresistor is the combination of words, photon, and resistor. It is a resistor which is dependent on light intensity. It is also known as light-dependent resistor. Symbol of the photoresistor are represented as image shown. The direction of two arrowheads indicates the falling of light on the photoresistor. The photoresistor changes its resistance when there is a change in the intensity of light. Let's have a small demonstration. Right now we aren't applying any light. So what will happen now? The photoresistor will detect darkness, and its resistance will increase, which will block the flow of current. But when we apply light source, the resistance of the photoresistor decreases, and it allows the current to flow through it. That's the basic principle of photoresistor. Using this concept we will build a small circuit in the TinkerCAD. Create new circuit, and rename the file to photoresistor. As usual, search for breadboard and battery, and make the connections. Now search for your transistor. Drag and drop this NPN transistor. Also search for LED and resistor. Drag and drop this photoresistor over here. Let's make the connections now. Move the LED over here. Place the resistor over here, right below the LED, and change the value to 500 ohms. Connect the other end of resistor to positive path. Connect the other end of LED to C pin of transistor, like this. And change the color to orange. Connect the E pin of this transistor to negative path. Place the photoresistor right here. Connect this pin to the negative path. Copy this resistor and paste it right here, connecting to the positive path. And change the value to 20 kilo ohms. And connect this pin of photoresistor to the middle pin of transistor just like this, and change the color to blue. Now let's simulate the circuit and see what happens. You can see the LED is glowing. If we click on this photoresistor, this end over here defines darkness, and the other end it defines brightness. And using this slider we can control the brightness and darkness for this photoresistor. If we slide it to this end, then we are providing high brightness to the photoresistor, and our LED turns off. And again if we slide it to the other end, the LED glows. Now our circuit is functioning like this. The current is passing through this wire, then to the resistor, passing through the LED, and then through this wire to the transistor, and completing the circuit through this wire. But you already know, to connect C and E pin of transistor, one must provide positive power to the B pin of transistor, which is provided by this small circuit including the photoresistor. Now let's simulate the circuit again, and have a look. The LED is already glowing. Because right now photoresistor is detecting darkness and no current is flowing through it. And the transistor is triggered by the resistor below. And if we slide this to the brighter side, the LED turns off, because now the current from the resistor is flowing through the photoresistor, and hence the transistor is not triggered. In conclusion, we can say that this small circuit is a darkness detector, where the LED glows when the photoresistor detects darkness. This circuit is already used in automatic street lights, where the street lights are switched on automatically in the evening, when the photoresistor detects darkness. That's all in this lecture. In the next lecture we will design logic gates using integrated circuits. See you in the next lecture.